So at this point, it's up to you with what you want to do. We have everything set up, so now you can mess around with, let's say, the scale of some of these booleans. You can add more tertiary pieces if you'd like. We still have a detail layer when it comes to that really fine particulate kind of stuff, but for the most part, everything's now here for you to tweak. In addition to that, we can also modify the bullet attributes going into the solver so that we can also optimize, make this faster, and make this behave a bit more realistically with the mass. So anyway, going back up here, before we start modifying all these different things, I want to make some groups that correlate with our primary piece, our secondary pieces, and our tertiary. I'm going to create a group and call this one our primary underscore group. And you'll notice that it turned to primary underscore group 1 because I have another group node somewhere in this network that's named primary group. So just watch out for that sort of thing. In this case, let's just call it primary without the group syntax. It's not the best organization to do it like I'm doing right here, but that's okay. We just need to clean everything that goes into it. So remove all groups and yeah, there we go. So I think we're fine now. On this primary, let's say that the group name is $OS. We're also creating groups for the points. So this will be a point group. And then for the group, the base group syntax, we'll say include anything with the name equal to primary to start. Omit, so that's a little caret sign, or don't include anything with the name that has anything to do with the letter S. And also don't allow anything which has a name value that has T in it. And it's kind of difficult to see in the viewport, but you can see that it has in fact highlighted this big piece. And if we want to see that a bit more easily, switch this over to primitives, and now you can really see where that is. On points though, it's still there, it's just a very light blue, so it's a little bit more difficult to actually see that. But it's there. Okay, so with that being the case, that gives us primary. Let's do the same thing now for secondary. We'll call this secondary. Also watch out for capital letters. That will mess you up if you're not careful. So I'm doing all undercase letters for this. This time say anything with the name S, but don't include anything with the T in the suffix. And then likewise with tertiary, we'll just go here, tertiary, and then you just go like that. And just to double check to be sure that these groups worked, let's use a blast and blast away based on group. So we're going to say it's going to be a point group here. And at the very, very, very bottom, we're going to have this primary. So there we go. We'll say delete non-selected. So that works. Call this secondary. And then finally, tertiary. So everything is grouped as expected. Now, because we have this, it's really awesome because we can use this with the RBD configure SOP to configure bullet attributes based on the size of those pieces. So let's say that I want to speed up my simulation by having certain pieces not collide with one another. That collision pass takes a long time on the solver, so if I tell the small pieces not to collide with stuff, it's going to speed things up quite a bit. Well, this is where these groups come in handy because now I can just say, all right, use tertiary like that. And for the tertiary stuff, go to collisions and check on collision ignore. And I want this to ignore everything. So star. And that will configure the bullet attribute just on those tertiary pieces. Now, just to make sure that this works, let's actually take our blast again and just isolate those tertiary pieces. So there's tertiary, again, it's points, delete non-selected. Okay, so we go there, geo spreadsheets, on the points, we do in fact have collision ignore and it has star. To check the other pieces, Let's turn this off, and you can see that collision ignore has nothing in it. So that is working properly, which is great. I'm going to name this our RBD, well, we'll just call this config underscore tertiary. And obviously, we can create a config for everything. So let's just say that this is now going to be a config for all. And what I want to do with this config all is go up to the top here, actually here in the middle with the physical attributes. And so this is something that I find all the time, by the way. People, they go through their simulations, they go through all these miles of hard work, but they forget to set the mass of the pieces. And it's a huge deal because the mass of the pieces will change the behavior by a drastic amount. When things are heavier or lighter, the collisions, they all change, gravity affects it differently, forces affect it differently. It's really important that we get an accurate mass here. And luckily, that's really easy with this RBD configure because we can go to the concretes and we can say earth compact and keep that at dry and clean. So now we have mass values that correlate with what these might actually be. Likewise in the .NET, what's cool about these groups is now we can also create pop forces that just impact certain pieces. So just to show you what I mean, if we create a pop force, and let's say that we plug this in, we can isolate, let's say, the tertiary stuff real quick. So there's tertiary. Let's turn up this noise right here, and we should see that it will just affect tertiary pieces as they become active. So I'll go forward a few frames here just to prove a point. And you can kind of see it. They are actually moving due to that curl noise now, and it's just those tiny tertiary pieces, which is great. So that right there actually added quite a bit already. Also, we could see that the bullet attributes are working now because these tertiary pieces aren't colliding with the ground anymore. If we turn that pop force up a lot more, we also notice that this is pretty cool because it gives us this almost explosive looking motion that's driven by those tertiary pieces. I mean, this is obviously exaggerated, but we can get some of that effect via isolating it with the pop force and setting this amplitude. So before I was at 5, this is 20. Let's go somewhere fairly in between, maybe like a value of 10. We don't want to overdo it, but we can really start dialing this all in now. And when it comes to these microsolvers, I'll let you guys just play with this and see whatever you come up with. A lot of this is what I taught in Destruction 1, so nothing new to what you already might know. There is one more optimization, though, that I'd like to show you before moving on to animation. And it's this whole idea that as pieces, let's say, get down here, right? I want them to turn off so that the solver doesn't think about them anymore. So I want the active value to turn to 0. That will speed things up. That way we're not calculating the movement of pieces that don't matter anyway. It's best to not delete them because if you delete them, it'll mess up the transform pieces down here. So the next best thing we can do is just freeze them. And anyway, let's create a SOP solver, and we'll plug that into the pre-solve. The idea here is that I want to create a group, and I want to say mask non-active. Let's go ahead and copy that, and then also do a point wrangle and say at active is equal to 0 whenever this group is happening. This is a point group. Also be sure that this is a point group, and we want to say $OS for the name. Last but not least, let's also put an output node. Don't forget that, because if you set the visibility up here like that, then it will just take whatever this node comes up with and the wrangle won't get picked up. The output ensures that everything gets heard. So anyway, as soon as we have that, we actually need to adjust this group though. Let's say keep in bounding regions and we're going to make this thing pretty darn big. We need to figure out how big our whole thing is. So let's go ahead and ghost other objects. And we might just have to kind of guess this one here for a minute. That's okay. We'll just, for right now, kind of wing it. Okay, so let's say we start there, and then let's keyframe this box here, though, so that it kind of goes up like that, and it freezes pieces as it goes up. So keyframe that at 1, and then let's say by frame 72, we'll do another keyframe, maybe right about there. So now we end up with that. Okay, so after doing that, let's go forward a few frames and see what happens. All right, looking pretty darn cool. What I'll do now is I'll bring back all the pieces. Let's see what it looks like when I do that. And what do you know? We end up with something like this. The one thing I don't like right now is how everything kind of drops at the same time. We're going to do something to fix that in the future. But for right now, the important thing is to move on to animation, because that will eventually drive when this activation happens as well. So stay tuned.